Welcome to the online platform of KTCD College of Arts and Science. I am RESHMISREE, HoD Department of Mathematics. This video is about CANTOR'S theorem. So before defining the CANTOR'S theorem, we have to define what is power set. You are already studied in your higher secondary class about the power sets. What do you mean by a power set? So, given a set A, the power set P of A refers to the collection of all subsets of A. So, the power set is the collection of all subsets of A. For example, let A equal to set ABC. Then the power set will be number of subsets, collection of all subsets. What will be the subsets? First we can write the null set. Null set is a subset of every set. So null set is one of the element in the power set. Next we write the single elements in the above set A equal to set ABC. That is set A, set B and set C. Next consider the two elements, set AB, set AC and set BC. Finally, three elements, that is the whole set. That is the whole set A. So the power set is the collection of all subsets of A. If here A has three elements, then the number of elements in the power of sets must be 2 raised to 3. 2 raised to 3 equal to 8 elements. Here null set is on set A 2, 3, 4, 5, 6, 7 and 8. So if A is a finite set with n elements, then the power set has 2 raised to n elements. Okay. If A is a finite set with n elements, then P of A has 2 raised to n elements. So now we are going to CANTOR'S theorem. So what is CANTOR'S theorem? CANTOR'S theorem states that given any set, there does not exist a function f from A to B, A to P of A, that is onto. That is, there does not exist a function A to the power set P of A, which is onto. So here also the proof is by contradiction. We assume that the function f from A to P of A is onto. So if f from A to P of A is onto, then f assigns every A belongs to A to some subset of A. Power set is a set of all subsets. So if f assigns every A belongs to A to some subsets of A, power set is a subset of A. The assumption that f is onto means that every subset of A appears as f of A for some A belongs to A. What do you mean by onto function? Onto function contains the range set. Okay, so every subset of A appears as f of A for some A belongs to A since f is onto. So the assumption that f is onto means that every subset of A appears as f of A for some A belongs to A. To arrive at a contradiction, we will produce a subset B subset or equal to A that is not equal to f of A. So to arrive at contradiction, we will produce a subset which is a subset of A that is not equal to that f of A for any A belongs to A. Okay. So for that we construct B using the following rule. What was the rule? B equal to set of all elements A belongs to A such that f of A not belongs to f of A. Such that A belongs to f of as A does not belongs to f of A. B equal to set of all A belongs to A. A belongs to A, but this A does not belongs to f of A. Is it possible? No, because the second set is a subset of all sets. Second set is the power set. It is a subset of all sets, so it will never happen. So we define a B such that it will happen. A belongs to A such that A does not belongs to f of A. That is, B is subset or equal to A. You all know that B is a subset of A. Power set is a subset of A. Given that f is onto. And so by the definition of onto, we can write B subset of A implies B belongs to P of A. P of A is the subset of A. So B belongs to P of A. That implies there exists A dash belongs to A. There exists A dash belongs to A such that f of A dash equal to B. Such that f of A dash, there exists A dash in A such that f of A dash exists in B. Okay, there exists A dash in A dash in A such that f of A dash in B. But by the property of B, but by the assumption of B taken by us is that if A dash belongs to A, then f of A dash does not belongs to A dash. So A dash does not belongs to f of A dash equal to f of A dash is B. So we get A dash belongs to B, but A dash does not belongs to B. From this set we get A dash belongs to A and f of A dash belongs to B. But from here we get A dash belongs to B, but A dash does not belongs to B, which is impossible. So if A dash belongs to B, then by the property of B, A dash does not belongs to f of A dash. That implies A dash, if A dash does not belongs to B, if A dash does not belongs to B, then what does it imply? It implies A dash belongs to B, which is also impossible. Okay. Therefore, no A dash belongs to A exists in A such that f of A dash equal to B. Hence, the function f is onto. We cannot find A in A with A does not belongs to f of A, since the second set is the power set of A. It contains all subsets of A. So image must contain some elements of A. Here we say that it does not contain the elements of B. So f is not onto. So we cannot find a function f from A to P of A to the power set, that is onto. Thank you.